vehicles in the car systems. What could have preempted, the further research into this, and today we are having this in place?
Naam, alhamdulillah, salatu wassalam ala rasulillahi sallallahu alaihi wasallam. Now, Brother Ayub, there is the major global problem of traffic accidents or injuries related with the road usage. Now, the UN tends to publish facts about some of these phenomena, and I'll give you just a few things for the recent report. Now, they are saying approximately 1.3 million people die each year as a result of road or traffic crashes. 1.3 million. They have not died of the disease, they have not been killed by anyone, but simply collisions on the roads. Now, more than half of all road traffic accidents or deaths are among the vulnerable users. So meaning either you are talking of pedestrians, people just are walking on the roads, or cyclists, people that are just using the simple cycles that are not motor. Then there are also the motorcyclists. Because, for example, if a person comes with a vehicle, even if it's just one person inside that vehicle, the entire vehicle with all its mass and capacity to destroy is now in the hands of this individual. So that simple individual can enter into a market and kill 20 people just with that single vehicle. Possibly that's why we get this disproportionate figure that the majority of people, again, are the ones that are just walking. They are not really users of the motor vehicles. Then they are saying 93% of the world's fatalities on the roads occur in the low or middle income countries. So these are countries like Uganda. Even though, interestingly, those low or middle income countries have only 60% of the vehicles in the world. So you see how disproportionate it is. The vehicles are just 60% in these poor countries, but they contribute 93% to the fatalities. And some of the problems that we think arise is over-reliance on human-driven vehicles. There is very limited automation in the majority of the vehicles that we see on our roads. Some of it is, of course, driven by affordability, but in some cases, there is even resistance. Because, for example, many times when vehicles that are being purchased here in Uganda, they talk of amasanyalaze chikule ina amasannyalaze mangi. So it becomes now a negative instead of being a positive. So the dislike for masannyalaze is driven by the fact that the ones repairing usually don't want to learn these new high-end technologies. They are used to their thing. They don't want to do any research. So when new vehicles come and they have some elements of automation, they see them as a problem, so they simply refuse to repair them, and it drives that vehicle off the demand area. So today we are therefore looking at technology that is available within the vehicles that can help to reduce the reduction in number of accidents in other countries. It's not because they are more disciplined or etc. Yes, the rules are there and the majority do follow, but the vehicles they drive are a bit safer due to the reduction on reliance too much on the human beings. So that is something that we shall need to look at. Now, automation in the vehicles is in a number of levels. It's not only one. So the normal vehicles you see here in the majority of Ugandan roads are what we call level 0. No automation. The human being is the one doing 100% of the control of the vehicle. So simple things like he has dozed off for 1 second can cause an accident. He has not seen the incoming vehicle, he's trying to overtake, he does not know there's another one coming from the other side, causes an accident. So level 0 automation is 100% reliance on human beings. And that's what we are saying, that is not very good. Then level 1, which is the next level, is the starting point. And we say it is the lowest level of automation. What does it do in this case? We do what we call driver assistance, meaning the human being is there, yes, but we try to remove some of the things that we don't do very well as human beings and hand them over to a machine to try and provide some support. So in that case, level 1, they talk of two things. One, try to provide some steering control. The steering itself has some automation in the way it is managed. It's not relying 100% on the input of the human being, although the human being can control it. But in case you sleep, the steering wheel can manage itself without necessarily relying on your input. Then the second part there is cruise control. Cruise control is issues related with the speed of the vehicle and its behavior relative to other vehicles. So the automation in that case is what we call adaptive cruise control, where the vehicle can be kept at a safe distance from the next car. So it is able to therefore at least manage that simple thing that would arise in case you dozed off. The vehicle would simply hit the one that is coming and that is in front of you. So
I think even in during jam there is always a distance that they usually tell us it should be between you and whoever is in front of you.
So that buffer that is put there for purposes of avoiding that collision that comes in case there is any lapse in attention. One vehicle hits the one that is in front of it. So here in this case the automation is we provide some machine control on the steering, then 2 machine control on the speed of the vehicle, and machine control on how it works. Now this is a graphic, although this one we shall need it when we are discussing the last level, which is where the vehicle takes full charge. But in the case of how does this vehicle actually detect that I'm too close to the next vehicle, etc., you have those technologies that are provided in that graphic there. There is what we call LiDAR, which is a light distance and ranging. In that case it uses a light to detect the incoming target. You can also use radar, like what is used for aircraft. You send an electromagnetic signal out, then the signal hits the next object and it returns information back. Then the GPS of course is for positioning, but those ones are applied mainly in the final level where the vehicle is taking 100% control of itself. So level 1, therefore, we have said you do some control. It is not 100% takeover. Some control on cruise. Do not allow the vehicle to come too close to others that are in front of it. Then the steering should be able to take charge and avoid the vehicle swerving off the road and some of these other things that cause unnecessary accident.
Where, it helps me, say for example, if I want to overtake,
yes,
so it is able to calculate the distance and at which the vehicle that is coming that I want to, say for example, I'm driving to Jinja Road, but there is another car that is coming from Jinja Road to Kampala. So in the due course, because many crashes come because somebody is overtaking but is not able to calculate well which speed at which the other vehicle that is coming from one opposite side coming, towards them. That
one is now level 2.
It's level 2.
Yeah. So in this case, the steering control is largely avoiding obvious errors like the vehicle going off the road simply because someone has lost focus, or the vehicle accelerating too much and hitting the next vehicle that is ahead of it. So those are the two things that come in, meaning the support in terms of overtaking and others that require some higher level of intelligence is the next level, which we are calling level 2. So level 1 we have seen, what do we automate? Automate control of the steering, avoid unnecessary going off the road just because the human being is a bit absent-minded. Then 2, do cruise control. Don't allow the vehicle to accelerate too much to reach the next vehicle. So meaning for as long as the distance is kept, the vehicle does not intervene, but in case it comes too close, then the vehicle intervenes and reduces the speed on behalf of the one that is driving. Now level 2, they are what we call advanced driver assistance. So the other driver assistance was just basic. some simple support to avoid the most common of the accidents. So in that case, the driver assistance platform does not necessarily take over control of the system. It simply supports this driver and makes intervention in case of a major problem. Now for level 2, where we have partial driving automation, is where the vehicle can control both the steering and acceleration by itself. Remember, in the other case we saw that so here the graphic summarizes what we are talking about. We saw no automation, then under level 1 driver assistance, then level 2 where we are now is ADAS, advanced driver assistance systems. So I have said in this case the vehicle is able to take full control of both the steering and the acceleration or deceleration. So in that case, meaning you can take your hands off totally and the vehicle would be able to manage itself. So they are saying this kind of automation falls short of full automation because there is still a human being sitting there. But this human being does not need to keep their hands on the steering wheel or on the accelerator. So you sit there so that anytime you want, you can take charge. You simply grab the wheel and you move. Meaning the vehicle is not taking over 100% control. But as we shall see, the ones that come at the other higher levels, you realize that the vehicle does not even allow intervention of the human being, because remember, in the case it does its calculations and it has to maintain a certain acceleration, maintain a certain angle of cornering. In that case, if it allows the human being to intervene, then the entire calculation would fall short. So level 3, which is the next one, is what we call conditional driving automation. Now for conditional, what they are saying, the vehicle is able to actually detect the environment around it. In that case, it comes to what you are asking about. I want to overtake. So this vehicle under level 3 is able to detect the environment. It has scanners, it's able to detect the incoming vehicles, detect the speed at which they are moving, and therefore make a decision as to what speed of acceleration should we have in order to be able to complete. Of course, the ones that design the systems allow for a buffer. If the vehicle has a maximum acceleration or a maximum speed gain of that would allow it to from 0 to 60 kilometers per hour, for example, in 10 seconds, in that case they don't put it on the bar itself in terms of accelerating towards the incoming vehicle. Otherwise, in that case, in case there is any problem with the road, then the calculation would be falling short. So they put a buffer. They say maybe if with the expected duration for accelerating up to 60 is 10 seconds, then we plan for 15 seconds. So that in case there is any problem, you still have a buffer of up to 5 seconds. In that case, it means that this vehicle will not allow you to overtake.
If it is just below...
if it is below 15 seconds. So in that case, the vehicle is able to intervene and take full charge. So environmental detection is something very important, and environmental detection, like in our graphic that they showed us earlier on, you have a number of technologies that help with the environmental detection. One, nowadays we have cameras. So the vehicle is mounted with cameras, so it's able to scan using photo information, and that is one way in which, so you can see this kind of this now full blast self-driven. That's why it has that large camera at the top, because instead of having this human being seated in there, the vehicle now has to do full situation awareness around it, so it needs a camera. But that module that is on top would have other technologies. So you can have a camera, you can have the radar for detecting objects that are in front, and with the rise of artificial intelligence, as we shall see with the other higher levels, now the vehicle is able to classify the obstacles. So for example, if it sends a signal and it's a cow in front, it should be able to differentiate between a cow, a goat, a human being. Otherwise, if it simply sends back the same information, so you can't know what to intervene and make purpose with. So in this case, we have said level 3, the vehicle has environmental detection capabilities and can therefore make some informed decision about whether to go slower or to move faster. But even at this point, they still allow for human override, meaning when the human being takes over the steering wheel, the vehicle does not resist, because at this point I think they were still believing that the human beings still make a better decision in some cases, because you may find the roads are not exactly ideal. Of course, some of these technologies, we need to underscore the point that the roads that we have around here, they may also do a disservice, because you may find, yes, there is no obstacle ahead, but the road itself has now become an obstacle in itself. You have to move around sometimes.
So we need to agitate for technologies that put potholes
as part of the. By the way, that's what we think should have been the direction of customized research for Africa. For example, if the other ones are building automatic cars and ETC, and for them they don't imagine that a road should actually have potholes. Yeah. In that case, our local engineering teams would now be able to investigate in terms of obstacles that are on the ground.
Well, even when we usually hear that overspeeding is the main cause of accidents, but as a person who drives in Kampala and elsewhere, I know for sure that one of the main causes of accidents, besides the speed, it is those potholes. Because at times people are negotiating where I'm supposed to pass. There is a big hole. Now I have to negotiate and go on the other person's lane. But again, also the other person is also cruising.
Exactly.
So we fail either to some little mistake in terms of a few seconds causes a crash. So that is a big issue.
Indeed, once the road surface is not very clear, the entire driving even loses structure, because you are expected to be in your lane, but now within your lane there is a prohibitively large pothole, so you are forced to now go into another person's lane. The other person maybe also has again another another pothole in front of them, so there is now that confusion. And with the pothole, you can't really know, there is no standard of how far you need to move away from the pothole or how much.
And at times if it is at night, you don't know how deep it is.
Exactly.
So you can't risk.
So you would end up finding that the decision as to how far one would go away from the pothole may not be standard. So the other incoming vehicle may imagine, yes, there is a pothole, but I don't expect this man to come half into my lane. Yet in actual sense, this one is afraid of the pothole to the level that he's willing to go half into the incoming lane, and it creates problem. Actually, like you have said, the speed now in this case is a major cause of accidents. The UN report indicates that every 1% increase in mean speed produces a 4% increase in fatal crash risk. So you imagine you are moving at 10 kilometers per hour, just increasing to 11, you are increasing the chances of you dying in case there is any collision by 4%. So you can see therefore that just moving from 10 to 20 kilometers per hour, you are nearly getting yourself into 80% fatality possibilities. And of course, given our health infrastructure, some people do die just because of loss of blood. Yes, there has been an accident, granted. The person has been injured, granted, but the person has been around with that injury for 2-3 hours, 4 hours, and has finally died out of loss of blood. So these are all things that add on to the risk, but we are focusing more on the vehicles themselves, and we are saying at level 3, this vehicle is now able to begin detecting some of the environmental elements. So vehicles that have this kind of technology, we have Audi, this German manufacturer. The Germans have been very serious in this area of automation. They are the ones that have done much of implementation. Even at a time when automation was not something very important, it was already there. Of course, automation has also been supported by the rise of the electric cars. So possibly we may need to have a different session for them because they have their own advantages, as it were. So that is level 3. The human being is still allowed to intervene, but the vehicle is at least able to detect some of the things that we see that could be causing some of these problems.
Okay, just right now, I think I guess we shall have to make a pause there and go for a short commercial break. Then when you come back, we'll pick up right out from there, inshallah. So stay tuned, don't go.
Eno ye Salam TV.
Nala Instant Noodles, the ultimate convenience. Just boil, season, stir, and enjoy the delicious different flavors. Get your Nala Instant Noodles today for a quick, tasty meal. Available in shops and supermarkets countrywide. For wholesalers and traders, visit Chapa General Enterprises, shop number 3, Chikubo, Kampala, Rafik Building. Nala Instant Noodles, boil, season, stir, and enjoy.
Explore, enjoy, and dance to the latest content, beats, and kawozi from Uganda and beyond. Simply go to your Play Store or App Store right now, find Afro Mobile, download it straight to your phone, and get started. Is it TV you want? Simply open the app, click on TV, select the channel you want, and watch live. Are you busy right now? Then check out On Demand or enjoy in your free time. Afro Mobile. The future is now.
Oh, you can touch this. Hey, but you can test it. Ooh, but you can test it. Everybody grab a bottle and sip some. It's Mirinda time, flavors and much. Tongue tingling, thirst quenching and bombastic. Oh, sweeter than sweet, bolder than bold. Flavors explode, making you go oh, you can test it.
There's no flavor like Mirinda, now in a fresh new look with the same great taste. Enjoy the tongue-tingling flavor of Mirinda Fruity, Orange, Green Apple, and Pineapple. Mirinda.
Jovia. Ng'oyolekera ku lugendo luno olw'obulamu. Nkuwa ekirabo eky'amaanyi agatazizibwa. Amaanyi okulabibwa n'okuwulirwa mu mawanga ag'ewala ennyo. Okutuuka buli wamu nga yadde togenzeeyo. Ensi yonna ng'ekuli mu ngalo. Okutambula mu biseera n'okumanya buli kimu ekirina okumanyibwa. Jovia, kino ky'ekirabo kyange gy'oli.
Tewali kkubo ku ki ky'osobola okukola omukutu nnandameggwa ogwa MTN.
Fe aba Nursery Recruitment Agency tukwaniriza gwe omwana ow'obuwala omunayuganda ng'olina passport yo wakati w'emyaka 21 ku 35 jangu tukutwale e Saudi Arabia okukola nga housemaid. Wasomako oyogera ku luzungu jangu weewandiise naffe ogenda okole tojja kwejjusa. Tusangibwa kyalo Wajjala ku opposite ne Mogas Petrol Station ku Muzikiti. Oba osobola okuba ku namba y'essimu 0702 334861 oba 0394 825219. Weebale nnyo.
Nursery Recruitment Agency.
Eno ye Salam TV.
Okay, dear viewer of Salam TV, we want to welcome you back on the program. Thank you for being glued to this television channel and being glued also to the Alhidaayah show every Monday. Please keep it up and invite the others also to benefit from what we share here. We want also to remind you that this program is, it is streamed live on our YouTube channels, and if you want to get any information that has, you have missed, you can usually find it on our YouTube channel. So, Brother Sekalima, before we went for a short commercial break, we had seen level 0, level 1, level 2, and level 3. Where you had made mention of the number of interventions at which stage it will overtake a human kind of intervention. So we are from the levels so far we have seen until level 3, we are still seeing the intervention of a person. So maybe when we continue, we can have a level where we have totally somebody overtaken and we don't have any kind of human intervention. So I think then we can move on right from there.
Okay, so we've seen up to level 3, and the major hallmark of level 3 we say is environmental detection, ability to detect what is happening around, either by the use of cameras or ranging technologies like LiDAR for light and the radar for normal electromagnetic radiation. And with artificial intelligence nowadays, the information makes a lot more meaning. So this graphic here shows us very well what we are talking about. So in the detection of environment, you can use cameras. For example, the camera that we see in the very first picture is able to visualize that this is a cow. So in that case, you don't need to form the picture out of nothing. You form it out of that visual image. Then the cow or any other object can still be detected using that LiDAR technology, which is using light for purposes of determining distance, because distance is very important. Before you decelerate to a safe speed, you have to be able to estimate the distance that is there. Then radar is also available. For it uses electromagnetic radiation, which is a bit better, because light is sometimes obscured by things like fog or any other environmental distortions. But in case you are using radar, in that case, whether it is fog or whatever disturbances, for it, it's able to still operate. Then the GPS unit is used for location. Because before you decide whether to make a corner or etc., you should be able to know exactly where you are, then on the road, and then you are able to move forward. So level 4, in this case now we begin to see what we call high driving automation. Here the vehicle allows for some human intervention, yes, but the vehicle is now also able to intervene. So in all the other levels from 0 to 3, the vehicle cannot override the human being, although it can assist the human being during the way they are driving. But taking over from human control is only possible starting with the level 4. So meaning the designers of the software that controls the vehicle, they provide for parameters. This vehicle should not make a corner beyond this angle at this speed. Meaning when you try to give that kind of instruction, you are accelerating at a very high speed and you're trying to make a corner, the vehicle would refuse to obey that kind of command. So in that case, you are sure that the human being can never make input that distorts and puts the vehicle into a situation that is not planned for. Because actually the majority of accidents do come from one subjecting the vehicle to an unnatural situation, depending on what it was designed for. You are moving very fast, a cow crosses abruptly, so you brake in a way that is not designed for that kind of vehicle, and in the end the vehicle either simply goes off the road, the tires are no longer able to maintain contact with the ground, or the vehicle simply rolls around because the stability has simply gone. And remember, many of the vehicles that we use here in Uganda are simple Japanese vehicles that have a small weight, meaning its ability to grab the tarmac is not very good. And remember, the road also, as we have already noted, is not very high caliber. So you end up, once you make input that is beyond the design of the vehicle, a level 4 automation vehicle would intervene and stop that input. Even if you press the accelerator, the vehicle would not allow itself to be accelerated to that level. Or even if you made those turns that are in what we Baganda call chiwalazima. Chiwalazima means you are now in a life and death situation, so you are making decisions that are not rational. So in this case, the vehicle would refuse, and instead the vehicle would make its own input. So for example, you may find you need to reduce the speed a bit before you can make the corner. So in that case, the vehicle would follow the normal or safe pattern and protect the individual. So this level of automation allows the vehicle also to be able to drive itself, although the human being still stays there waiting to intervene in case there is anything serious, but the vehicle can move around. But as you may be aware, in many countries they have not allowed this business of a vehicle driving itself too much. So what they do, they create zones where they are sure even if there is a problem, the road is big enough and it would allow the vehicle to do whatever it wants to do without necessarily intervening and causing accidents. So legislation is still slow because usually the politicians are the ones that make some of these laws, and many times the politicians, they may not necessarily apply a lot of scientific processes when they are making their decisions. For as long as people are still worried, the politicians would push the thing aside. Yet in actual sense, we think that some of these machine-based interventions can actually provide the line between safety and non-safety. Because remember, although there are laws that prohibit people driving while they are drunk, but you know that whenever there is a kaunyemu operation, very many people are arrested on the road, clearly drunk while driving. Meaning, at least the human factor cannot enforce 100% compliance. So if these vehicles are at least automated in such a way that even this drunk man won't enter commands that are very awkward, the vehicle is able to detect that this speed is too high compared to the road situation, at least a few lives would be saved, especially for the innocent pedestrians and other people that move around.
Brother Hamza,
yes.
Just to make it a bit clear here, I see a situation of clashing. Say for example, the automation system is saying this command, and myself I feel it is not the right command. So there is a clash in interest. Well, this is a machine and it is just programmable. For as long as that is how it has been programmed, it will not apply other kind of factors to make a rational decision. So me, besides that, I also put the human intellect depending on what I feel is right at that moment. So there is a clash in there. How will that be reconciled?
So that one can only be allowed at level 3. Level 3 is where you take charge. The vehicle cannot force you. As long as you make the input, the vehicle will not intervene. But the vehicle can allow itself to make the input. But under level 4, the vehicle controls the input, meaning you can't argue with it. If you make a corner that is prohibited, it will simply ignore the corner and proceed along a pre-programmed path that guarantees safety, because remember it has environmental situation awareness, so it's able to detect the very things you are fearing and you're trying to make all these corners around. It is able to detect and also able to move forward. Of course, a challenge comes with our abnormal roads, that for you may be making this decision on the basis of the current speed and the pothole that is ahead. Remember, all these technologies that we are talking of, the LiDAR, the radar, they are all detecting objects that are above ground. The pothole is on the contrary, below ground. It is in the, so you may be making that decision because you've seen a pothole, the speed is a bit high, but the vehicle is making the decision on the basis of stability, meaning if we brake at that rate, we shall lose contact with the ground, and the outcome is very big. So in that case, you may end up hitting the pothole due to that anomaly. And like we have said, if only we engineers in the African context were able to add these kinds of additional modifications to these models, we would be making a positive addition. Because actually, for example, in the domain of vehicle technology, I don't think there is any African country that is going to deceive itself that it can chase the Japanese, find them, overtake them. That is now out of the way. But if we could start with what is there as of now and simply add on starting from there, meaning I have vehicle automation models that do not consider potholes. So in that case, I would now work on how do I actually detect a pothole.
And I think as this era that we are in, some of the inventions that have been made and innovations, you don't need to start from scratch. You just simply kind of put some innovation on already the existing.
Exactly.
So I think some of many countries that have done this very well are the Iranians people. You know, simply they will look at your technology and see how they can twist and maneuver, and the Chinese themselves.
You don't need to start from zero. You simply pick. And interestingly, some of these technology components are not really patented as in the small components. So you may find, for example, you have vehicle automation, and it's divided into modules. Some modules are for obstacle detection, others are for acceleration control. So you may find these are actually manufactured by different companies. So you do merge them, and you can be able to work with some of these companies only in their components. So for example, we are talking of collision detection in terms of objects that are ahead of the vehicle. Then in this case, we could talk of how about the ones that are below the vehicle and some of those other things. And we would be able to make improvements. But we are covering this content with the thinking that sometimes there are technology jumps, meaning today you may think Uganda has no automated vehicles, but in just 2 years, these vehicles are around the corner, especially as legislation is coming to control issues of pollution and other things. You may find the government
like I've heard it in the corridors that here, you know, we are at high speed to have electric cars here.
So you can see, in order to control pollution, we may now go electric car direction. I remember most of the electric car models are very recent. We don't have electric cars of 1990 or 2000. Many of them are just recent. So you may find they are available. And as more companies enter into this industry of electric cars, you'll find the cars are becoming a bit more affordable. And they are, for them, since the entire vehicle is already running largely on electricity, some of these automated systems are easier to implement. The last form is level 5. Now level 5, they even eliminate the human control elements. So they remove the steering, they also remove the accelerators. So in that case, if you are in there, you are seated there and you are just waiting to be driven. You are just waiting to be driven. Of course, they put in a lot of safety controls. Much of this has not been permitted for general public use, but the vehicles are already there. The Google people started on research in this area a long time ago, and the vehicles are in place.
I've seen some with Tesla.
So companies like Tesla are also coming in, and with the AI, things are becoming a lot easier, because sometime back the automation was largely using just semi-automated models. You build a rigid structure, it responds according to input. But with artificial intelligence, it is able to build its own models and to learn, and possibly those are the ones that can be more adaptive to environments like our roads here that may not be ideal. So in that case, the model adjusts and looks at the road itself, what surface is available and how far it can go. So these technologies we are saying are useful in reducing possibilities of accidents. Like we have seen, the majority of accidents do occur in the poor countries. And we can't claim that the poor countries have these accidents merely because of the fact that they are poor or that the others are more skilled in driving. Yes, road users without licenses exist everywhere. Road users that speed without consideration exist everywhere. Actually, it is very interesting, but most of the studies that are done about the way people drive in the Gulf, they were saying the people in the Gulf don't drink, but the way they drive is so bad that once you move into the road and you are driving, you just pray that someone is not going to come and ram into you. The person is not drunk, but the way they drive, and remember the user have the money to buy all these very fast moving SUVs, so chances are very high you could get hit. But in case much of this automation is available, the vehicles can be able to detect, and you find the number of accidents are reduced. So that is the 5 levels. We have said there is level 0, totally no automation, Ugandan style, everything is there. And remember,
but in Uganda we have because
automatic
we have
transmission
automatic and the manual. So I mean,
now automatic
and you know, there is always this debate that somebody who drives an automatic car is really somebody who doesn't know how to drive. It's just you know, somebody masquerading, you know, trying to turn. It is only those that have learned the vehicles in, you know, in manual and are driving manual cars. These are what they consider themselves as real drivers here in Uganda.
Anyway, they are still stuck with that mentality, but it's not accurate, because principally you can see we are moving towards eliminating human input. So you can't again drive us backward, making human input appear something very important, because like we have seen, human input is subject to a number of distortions. A person simply takes one glass of alcohol and he ceases to be the other person that was well trained in how to drive, begins to make inputs that are not reliable.
Actually on road, just 2 seconds of
distortion from normalcy can result
somebody is having a slip of just 2 seconds.
2 seconds, and you are relying 100% on human control. This person has lost just 2 seconds of attention, either via phone. That's why we are not supposed to be texting while driving, etc. But you'll find people do it. People do take calls, and they only stop the call in case they see a city card, and they even tell the person on that side, why? Then he drops the phone so that they are not seen. So all of these human problems do cause these high-risk elements that result in all these traffic accidents. Actually, when you see the statistics, when you are reading them, you see them more as outside, but when you are walking on the road and you are exposed to some of these dangers, some of us work in Mbale, so you are exposed to highway situations for 250 kilometers every week, actually 500, because you do the back and forth. So you have a very high risk of some of these problems here occurring. And remember, many of the roads are under repair or etc. But we are principally saying automation reduces some of these risks. And if we can be able to look at the available options, see if we can have some of these vehicles that have some safety features, even if it may be level 3 where it simply provides advisory, still it's better than the one that is not having anything. You can see vehicles that have this back-looking camera. At least you can see that in that case, however unserious you are seeing the obstacles at the back. So it provides you that information that you'd not be having under normal circumstances.
Yeah, at least for what we have on the Ugandan market, there are a few improvements as opposed to what we used to have in the previous years. At least we have even airbags, you know, things like we have, we call them child locks
in there.
So at least a few things that have been improvised, and there is some little kind of safety.
There is also ABS. ABS is what? Auto something braking. What helps the ABS system, if you read about it, helps you to not to brake in such a way that you end up losing contact with the ground. So even if you press the brake in an unnatural way, the ABS system would allow the vehicle to brake in such a way that it does not again skid, because once you start skidding, the entire braking system now loses meaning. So this technology is already available in some of these, actually the majority of cars, even the ones that are 2020 or anti-lock. It is called the anti-lock braking system. So it allows you to avoid skidding while braking. So all these are technologies that we should be at least able to utilize in case we have access now.
So okay, as we wind up, there is really something that I've picked from this program. One is there is really a lot that we need to do in our countries, at least to get the levels of having these cars.
Exactly.
Otherwise, as we have the infrastructure that is available today, we are not to that kind of measure that we can be able to have these cars accommodated here. That is one. And two, there is a lot of training in terms of people who are running driving schools. Even themselves need to go back and train so much so that we can have these vehicles right out here. Otherwise, the way it is right now, we can't, learning on job when you are risking people on the road, it is very risky. So I think our government can take up for this as we go for for more years to come. Technology is evolving day by day. We need to have this kind of infrastructure, improved, and even the people who are running driving schools to be able to also to up their game. So please, as you can have your parting shot in a minute.
Okay, now at our parting comments, actually the anti-lock braking system we talked about, since it's available already in many of the vehicles we are having, we could just talk of it, then we can conclude. So what it does is to reduce the distance of braking, meaning if under normal circumstances you'd take 2-3 meters, this one can reduce it to 1 meter. The design is in such a way that it forces the vehicle to press more on the ground and therefore have more impact, more grip on the ground, and it's able to therefore stop the vehicle. So therefore, when you are buying vehicles and you see ABS is included, you may not just look at it as some fancy additional features. Braking is one of the most important features that we have for accident control. At least if you see the problem and you can be able to stop the vehicle or reduce its speed, you all the time reduce on the possibility of the accident. So for our viewers, we thank you for being around and being able to look at some of these technologies. We are saying all this, we discuss it with the spirit that people should be interested in technology. It has so many benefits, but if we keep ourselves just stuck to our old ways and unable to appreciate some of these simple tools that people think very hard and come up with in order to protect us, then it becomes a bit of a problem. So we have seen automation in the vehicle environment. Possibly next time we shall look at some other safety elements that are available maybe in electric cars and others that don't necessarily use the normal engines that we know today. Assalamu alaikum wa rahmatullahi wa barakatuh.
Assalamu alaikum wa barakatuh. With that, we come to the end of this program. Inshallah, until next time when we meet next Monday. Subhanakallahumma wa bihamdika, nashhadu an la ilaha illa anta, astaghfiruka wa atubu ilayk. Assalamu alaikum wa rahmatullahi wa barakatuh.
Eno ye Salam TV. Adhan ngekutuswako Hotel Africana.